بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 3.3 Gauss and Jordan elimination. Here the augmented matrix is given and find the solution of the system. The first column is fine. In the second column, I need this number to be 1. I can divide by 3, but if I look to the third column, the third row, if I divide row 3 by -2, I can make this one without having fractions. So 4 over -2 is -2, and I have here 0. And now I can interchange row 2 with row 3. And I'll have 1 in this position. Now I use this one to make 3 and 1 zeros. So -3r2 plus r3 and -r1 r2 also plus r1. We will replace row 3 by -3 row 2 plus row 3, and we will replace row 1 by -r2 plus r1. So -1 plus 1 is 0. -3 times -2 is 6 plus 1, 7. Now this has to be 1. And I have no other choice here. In the last row, you need to just divide by this number. And now I need to use this one to make these two numbers zeros. If this is 4, you multiply row 3 by -4. Row 3 is not changing. 2 plus 0 is 2. -4 plus -1 is -5. So x is -5, y is 2, and z is 1. Here, this number is 1, but I need these two numbers to be 0. This is a 3, you multiply row 1 by -3. This is 1, you multiply row 1 by -1. Row 1 is not changing. And now -3 times 1 plus 3 is 0. -3 times 1, -3 plus -2 is -5, and so on. Also here, -1 plus 1 is 0, -1 plus 2 is 1, -1 plus 1 is 0, -3 plus 4 is 1. Well, this number is 1, and I need the -5 to be 1. So I'll just interchange row 2 and row 3. And now I use this one to make these two numbers zeros. So 5 r2 plus r3 and -r2 plus r1. These two operations will replace row 3 and row 1. Negative row 2 plus row 1. Five row 2 plus row 3. Finally, this number has to be 1. It is 1, so I use it to make this one 0. So negative R3 plus R1. Negative 1 plus 2 is 1. This is the identity matrix. So X is 1, Y is 1, Z is 1. Use row operations on augmented matrices to solve the given system. So let us find first the augmented matrix. Coefficients of X, coefficients of Y, coefficients of Z. I need this number to be 1, so I will divide by 2. I'm dividing row 1 by 2. Now I use the 1 in the first column to make 3 and 2 zeros. 3, so I multiply row 1 by negative 3. 2, I multiply row 1 by negative 2. These two operations will change row 2 and row 3. Row 1 is not changing. Negative 3 plus negative 3 is 9. Minus 10 is negative 1. 18 minus 20 is negative 2. Negative 9 plus 5 is negative 4. Negative 2 times negative 3, 12 plus negative 17. Negative 6 and minus 4 is negative 10. Now I need this number to be 1. So just negative R2. I use this one to make 6, 0 and negative 3, 0. Negative 6 plus 6. Negative 12 plus negative 5. Negative 24 plus negative 10. 3 plus negative 3. 6 plus negative 6. 12 plus a 3. So now negative 17 has to be 1. Negative 34 over negative 17 is just 2. Use this one to make the 2, 0. Negative 2 plus 2 is 0. Negative 4 plus 4 is 0. So x is 15, y is 0, and z is 2. This is the solution of the system. Another system, the augmented matrix. Pause the video and try to solve it by yourself. You have to practice because it's easy to make mistake here. This is the augmented matrix. All right, I need this number to be 1. Negative 3 has to be 1. Well, I can divide by negative 3 and I can interchange. Since all numbers are divisible by negative 3, so I choose to divide by negative 3. Please, you can solve it in another way, no problem. Interchange and get the same answer. 6 over negative 3 is negative 2. Negative 9 over negative 3 is 3. 3 over negative 3 is negative 1. I use this one now to make the 1 in the second column, in first column, second row 0. So negative R1 plus R2. Negative 5 R1 plus R3 to finish working with column 1. Negative R1, so 2 plus minus 1. Negative 3 plus minus 2. Negative 1 is 1 plus 0. Negative 5 plus 5, 0. 5 times 5, 10. Negative 5 times negative 2, 10. Minus 7, 3. This number is 1. That's good. So I just use it to make the 10, 0 and the negative 2 above. Two plus negative 2, negative 10 plus 3, 2 minus 1, negative 10 plus 10, 50 plus 3, negative 10 plus 63. Now I have to divide by 53. 53 tells me that everything is fine. Now negative 5 and negative 7 has to be 1. Using this one. And this would be the last step. 5 plus 1, 7 plus 1. So x is 8, y is 6, and z is 1. A system and a reduced matrix are given. Use the reduced matrix. So this is the reduced matrix. He did all the operations for us and found the reduced matrix. So use this reduced matrix to find the general solution of the system if one exists. Well, here 0 equals 1. This is not possible. So there is no solution for this system. While here we have 0 equals 0, so we will have infinitely many solutions. So let me write the equations. X plus or minus 2 over 3 times z is 11 over 3. Y plus 1 over 3 z is negative 1 over 3, and 0 equals 0. So I solve for x and y. And z will be a free variable. It could be any real number. He said in part B, if multiple solutions exist, find two specific solutions. So this is part A. Part B, let us find two specific solutions. I'll choose z to be 0. So x would be 11 over 3, and y would be negative 1 over 3. This is one of the solutions. Second one, I choose z to be 1. Okay. Then x would be 2 over 3 plus 11 over 3. That's 13 over 3. And y would be negative 1 over 3, negative 1 over 3. That's negative 2 over 3. So this is another solution. And you can choose z, any real number, and every time you will get a new solution. The system of equations may have unique solutions, infinite number of solutions, no solutions. You use matrices to find the general solution. Okay. Augmented matrix. And here I have zeros. Well, if I divide by 2, I'll have fractions, so I'll change with the second row. I can write 2, 1 or 1, 2, it doesn't matter. So I interchanged row 1 and row 2. Double checking that everything is fine. Now I use this one to make 2 and 1 zeros to finish working with the first column. This is usually our method. First column 1, 0, 0. It should be like this. So negative 2 plus 2 is 0. Negative 4 plus minus 1. Negative 4 plus 3. Here we will have always zeros because anything times 0 will be 0 plus the number, so no change. Now negative R1 plus R3. Negative 2 plus negative 3. Negative 2 plus 1. You can see that you have the same column, the same row. So we will have infinitely many solutions here. Anyway, I will write it in the reduced form. So I will divide row 2 by negative 5. Negative 1 over negative 5 is 1 over 5. And now use this one to make these two numbers zeros. So negative 2 R2 plus R1 and 5 R2 plus R3. Negative 2 over 5 plus 2. Do it by calculator. 5 times 1 over 5 is 1, plus minus 1 is 0. So I have x. Now I cannot continue because this number is 0 and I cannot make it 1. So I stop here, and that's the reduced form, and it satisfies all the conditions of the reduced form. I have 1 in the first non-zero element in the first row is 1, and all the numbers below are zeros. The first non-zero element in the second row is 1, and above and below we have zeros. And in the last row there are no zero all are zero elements. So let me write the equation. X plus 8 over 5z equals to 0. Y plus 1 over 5z equals to 0, and 0 equals to 0. So I solve for x and for y, and z would be any real number. And for part B, I can choose z to be 0, for example. And then x would be 0 and y would be 0. I can choose z to be 1. Then x would be negative 8 over 5, and y would be negative 1 over 5. Another question, augmented matrix. This is the augmented matrix. All right. I need this number to be 1, so I interchange row 1 and row 2 because row 2 has 1, the first element. Ah, 3, 2, 1, 0. 2, 1, negative 1, negative 1. I need to use this number, which is 1, to make 3 0. So negative 3 R1 plus R2, and negative 2 R1 plus R3. The first row as it is. Negative 3 plus 3, 0. Negative 3 plus 2, negative 1. Negative 6 plus 1. Negative 6 plus 0. Negative 2 plus 2, 0. Negative 2 plus 1. Negative 4 plus minus 1. Negative 4 plus minus 1. So I can tell here that the system has no solution because I have negative 1, negative 5, but these two numbers are different. Anyway, I will write it in the reduced form. And I have to use this one to make this one 0. So negative R2 plus R1 and R2 plus R3. Negative 5 plus 2. Negative 6 plus 2. 1 plus minus 1, 5 plus minus 5, 6 plus negative 5. So you can see that I have x minus 3, z equals negative 4 and y plus 5z equals 6, but I have 0 equals to 1, and this is not possible. So there is no solution for this system. Another question. The augmented matrix. Pause the video and try to solve it by yourself. Well, I need the first number to be 1, so I will interchange with row 2, row 1 with row 2. You can interchange with row 3 if you like. There is no problem. You should get the same answer. Okay, so I use this one to make 2, 0, and to make this one 0. The first row remains the same. Negative 2 plus 2 is 0. 2 plus 1 is 3. Negative 4 plus negative 1 is negative 5. Negative 6 plus 2 is negative 4. And negative, this is R1, okay? Negative 1 plus 1 is 0. Negative times negative positive 1 plus 1, 2. Negative 2 plus negative 1 is negative 3. And negative 3 plus 1 is negative 2. Well, I need 3 to be 0. So I will divide by 3. Well, I prefer to divide by 2. So I will divide row 3 by 2. Negative 3 over 2. Negative 2 over 2. And now I will interchange row 2 with row 3. So now I have 1 in the middle. This is 1. I use it to make 3 and negative 1 zeros. So negative 3 R2 plus R3 and R2 plus R1. So I replace row 1 and row 3. Row 2 is kept without change. 1 plus minus 1. Negative 3 over 2 plus 2. Negative 1 plus 3. Negative 3 plus 3. Negative 3 times negative 3 over 2, 9 over 2. Minus 10 over 2. 3 minus 4. Now I will multiply row 3 by negative 2 to get 1 instead of negative half. Negative 2 times negative 1 is 2. So I have z now, and I use this one to make these numbers zeros. Negative 3 over 2. So I multiply row 3 by 3 over 2. Half, I multiply row 3 by negative half and add it to row 1. This is row 3. Now 3 over 2 times 2 would be 3 minus 1, that's 2. And negative half times 2 is negative 1 plus 2, that's 1. So x is 1, y is 2, z is 2, and that's the last example. I hope you enjoyed solving with Gauss and Jordan elimination.